This question, quite a complicated one. You need to either use tree diagrams or not. I will use a tree diagram for part B. I won't for part A. The probability that the first three trains leave on time is leave on time and leave on time and leave on time. You must learn that and goes with multiply and or goes with plus. That's really fundamental for probability questions. Now read this carefully. No trains leave early. The first train leaves on time is a probability of 0.9. For all the other trains, if the previous train did leave on time, the probability that leaves on time is 0.8. And if it did not leave on time, the probability this train leaves on time is 0.65. Now we're not concerned with this in the first part because we're only interested in the first three trains leave on time. The chance that a train leaves on time is 0.9 because it says so. The chance that the next one leaves on time, if the previous train did leave on time, the next one has a chance of 0.8. And if the previous train left on time, the probability the next one leaves on time is 0.8. So this is 0.9 times 0.8 times 0.8, which I'm just typing into my calculator now, and I get 0.576. Now part B is more complicated. The 2 p.m. train does not leave on time, so we know that's already happened. So we don't need to work out the probability of that because that's happened. We've got to work out the probability that exactly one of the two next trains does not leave on time. So, okay, so we need like a tree diagram that goes second train and third train. So that's the next two trains. We know about the first train. So it's kind of like this tree diagram. So the second train could be on time, OT, or late. And the third train, if the second one was on time, it could be on time or late. If the second one was late, it could then be on time or late. There are four different possibilities happening here. Okay, so the chance, so we know that the 2 p.m. train, the first one, does not leave on time. If the previous train did not leave on time, the chance this train leaves on time is 0.65, 65%. The chance it's late then must be 35% to make 100%. Now, we've got to watch what happens to the next bit. If that's on time, then the chance the next train is on time, if the previous train did leave on time, this is going to be a 0.8. Outcomes at the end of the branches, probabilities on the branches. If it's a 0.8, it must be a 0.2 to make 100%. If the previous train did not leave on time, the chance this one leaves on time is 0.65. It's just all about reading this wording. And the chance it's late must be 35%. Now, work out the chance that exactly one of the next two trains does not leave on time. So we're not interested in them both being on time. We're interested in this one being on time and this one being late. So we want that one. That is 0.65 multiplied by 0.2, which we can type in a moment. But we're also interested, exactly one does not leave on time. So one late, one on time. We also want this one. We don't want both late. And this one is a 0.35 times a 0.65. And we must add them together because either this will happen or this could happen. And they can't both happen. So it's that or that. So ready for the calculation now. 0.65 times 0.2 plus 0.35 times 0.65. And that comes to 0.3575. Tricky, that one.